Hi, everyone, and thank you very much for coming to the talk. So I want to talk a little bit about, not really about specific products, but really just the notion of how do databases fit in with Agile software development life cycles and methodologies. So who here is doing Agile development? Who here is doing development, non-Agile development? Okay. So it's certainly very popular and makes a lot of sense to me. I'm a huge fan, and a huge fan of just the general notion of iteration, right? And I think that's actually something that can be used more than it is in business in general, right? It doesn't have to be code, right? You can iterate on lots of things, marketing materials and approaches to sales and things like that. So I think there's possibly things there that could actually be lessons learned that could be taken elsewhere. But anyway, we're not going to talk about that. We're going to talk about software. So just to make us think, what's the first thing you think of when you hear RDBMS? I just think database, just because it's been the only game in town for forever. So first thing I think of when I hear SQL, I think, well, beyond just thinking of the literal meaning, I think about reporting, right? Because I'm thinking about ad hoc queries, things like that. That's the first thing that pops in my head. Obviously, that's kind of the idea of the question. What's the first thing you think of when you hear NoSQL? And if you know what it is, right? The name is sort of a weird name, so of the space. But I think, even for me, but I think for most people, they think about scale, right? They think about big data, they think about horizontal scale out, right? I think that's pretty common. But it's not all about scale, or I don't think it should be, right? I think if we're going to do something new, if we're going to do something non-relational, that's a huge shift. Everyone who's a developer knows relational database theory and understands it and has used it. And so to shift from that, we better have a good reason. And the imperative to scale is a good reason, right? But it'd be nice if we get more out of that switching cost, if you will, than just that, right? So if we're going to do something new, my point of view on it is this really creates an opportunity, right? This stuff doesn't change that often, and at least it hasn't historically. So what else can we do? Can we get more out of it than just infinite scale out horizontally, right? And I think we can. I think we can try to make software development, building applications, better and easier and more productive. Object-oriented programming, Agile development, the programming languages we use today, the architectures we use today, service-oriented architectures, all of this stuff, it didn't exist when relational theory was invented, right? So it's not surprising if the mapping of all that stuff on top of it isn't perfect, right? And it's not relational's fault, because it is the older of the set of things. So we should be thinking about all those things, though, if we are going to try to do something new, and that's what we've been trying to do with MongoDB. So it's really, there's the scale part, but can we really make development better, too? If you try to do both, I think it makes the problem to be solved a little harder, but it doesn't make it intractable, right? So that's our philosophy. Most of the NoSQL products, or even maybe all of them, have what I would call a dynamic schema, right? It's easy to add extra fields or columns or whatever you want to call them. So that's pretty interesting, and that really does fit super well with iterative development, right? You do a release a week, and there's a new field this week in some collection. Not really a problem. Right? On a traditional database, though, it creates some work, right? You do a release a week, you might have a schema migration script a week and a rollback script just in case it doesn't work, and all that kind of stuff, and maybe maintenance windows. So that is really kind of the crux of, or point one of why there's a synergy between these products and this methodology, if you will. But one thing that is really important to remember is there is a schema, right? It's common with these products to call them schema lists, quote unquote, but that's imprecise. Because you must design a schema when you start the project. If you do not, it's not going to go well, right? If you just wing it. So that schema design step of the development is just as important as ever. But we have to be careful there because you're not forced to do this thorough, thoughtful thinking about schemas up front, right? So there's the potential to, be lazy, and then you'll end up with something suboptimal later. And so there's a lot of things to think about. Just what is the right general shape and schema for the system? There may be implications based on the product that the schema has. With relational databases and the schema design, conceptually, usually there's a correct schema, right? Like a sort of a normalized third normal form type of schema. Give me your entity relationship diagram. I can do a schema that'll be reasonable, even without knowing what you're going to do with the data, right? It won't be unreasonable, right? With these products, and certainly with MongoDB, which is the one I know well, it's different. You don't design the schema for the data abstractly. You design a schema for your bread and butter use case. So you do schema design, but what you do is inverted. It's like 180 degrees different. So you're really designing for the specific use case. And in part, that's because you don't have joins, right? So some things are going to be harder or easier to do depending on what schema you pick, right? Like in MongoDB, if you're nesting and embedding, doing rich operations on those documents in and of themselves will be easy, but if you're spanning documents, you're going to have to write some code. So the approach is different, but the design is very important, and there's other implications too. If the product lets you do atomic operations within the scope of single documents, but not wider, if you need to do that operation, then you should think about that as you design your schema. And I think in most of the products, you're selecting a partitioning key, right, when you scale out. So selecting that shard key or partitioning key is part of the schema design, and that's something that's hard to change later, right? So that's something that's pretty important to get right up front. And then, of course, the schema is going to evolve because we're iterating, right? But a lot of times the changes are frequent but small, right? So not always, but often. So just to make it a little more concrete, let's suppose we're writing a CMS, some kind of content management system. We have post in it. So we start coding, and we're doing Agile. So we're going to build some minimum viable app and release it internally at least. And so here we have it. We have these news stories or whatever. So one document per story in a post collection or something like that. There's lots of the NoSQL products you could do something analogous to this with. So we do that. So great, we release it, and now we're going to do some more work, right? So we're going to, let's say we want to now let people write comments. So we're going to build in some sort of commenting module or subsystem into this CMS, right? So if we do that, you could imagine these documents then evolving to have this kind of a structure to them, right? Where you have nested comments within the document. You could have them in a different collection, but you can imagine them embedded here. And the point is just that change is seamless. When you release the new version of your app and it suddenly adds a comment to an existing post or creates a new post with a comment, the system will just accept it and not complain nor do anything bad, right? And in addition, I suppose in a relational database, if you added a new table, which was comments, that's pretty seamless, right? Because it didn't exist before. But if you were to change your post table to have extra fields, that would be a little less seamless. And then it's important too, though, that I can do operations with this data, right? So in a lot of these products, they're not just key value stores, right? They're not just get set by primary key, storing some value that's an opaque blob. Blob might be JSON, but it's opaque. You know, a lot of the products let you reach into documents, and they understand semantically how to do that. So, for example, as a MongoDB query, you know, find me all of the posts where Jane was a commenter, right? So you can do things like this, and you know, it's about, if you imagine sort of doing this in relational, your query would be no shorter in this particular case. But of course, that's because I designed a schema that facilitated this in the first place. And you can also, you know, you could create an index on that too. So you can do these kind of things. So the point of this is a fairly simple example. Is just that you can kind of to just get a feel for kind of the rapidity at which you can do some of these things, hopefully. Let's say we want to do more, though. Let's say we want to let, in our CMS, we want to let people vote on which stories they like, right? And we don't want anyone to vote more than once. So we could do something like this, where in each post we have how many votes it has and who voted. You know, so we remember who voted so that you can't vote twice. Right? So you can imagine doing something like this, and this is just kind of our flow of iteration of releases. And then once again, the database can reach into these things and do something. So if someone wants to vote, we could do a statement like this. And sorry that's so low, but we got 2 screens, so we're probably OK. But this is sort of, you know, update post where ID equals this, and this user ID is not already in the voters array. Set increment votes by 1 and add them to the voters array, right? So once again, you know, it's pretty easy to do this. And another interesting property in the MongoDB case is this is an atomic operation, right? So you can't have a race where this person votes twice. So that's an example of why the product has some support for atomic operations. There's a wide variety in the NoSQL space of consistency models, and it's sort of like a dial a little bit, or gradient. And but this is why we wanted to have some strong consistency capabilities, not fully generalized complex transactional semantics, which I think is probably intractable on 1,000 server clusters to do, right? If we make some assumptions and simplify assumptions, you could do some things. But we wanted to have at least these micro transactions, if you will, kind of for reasons like this. Or another example would be just new user registration. You know, you pick a username. Oh, sorry, that name's already taken. Or thanks for registering, you got it. You don't want 2 people to register for the same username at the same time. So that would be another example of something where you might want an atomic operation. So these products have dynamic schemas. So I wanted to make an analogy to programming languages, right? So in programming languages, we're used to having either statically or typed or dynamically typed languages, and they each have their pros and cons, right? So Java is statically typed, obviously, and JavaScript being an example here of a dynamically typed language, and as well as many others like Ruby or Lisp. So personally, when I'm coding, I'm a big fan of statically typed languages, especially when the projects get bigger, right? Because it's really nice to get those errors at compile time and not at runtime, right? I don't want to write a bunch of unit tests just to catch something the compiler could have caught, right? The dynamic stuff is nice, but it depends what you're doing, right? So by default, I think I like statically typed languages a lot for that reason. It also fits well, ironically, statically typed languages fit kind of well with Agile development because you do a lot of refactoring. And you know, I know like when I'm working on MongoDB or something in C++, you know, if I want to change what's going on with some piece of data somewhere in the code, you know, if I just comment out that field, I'll then get compile errors everywhere it's referenced, right? And then I can go refactor each of those places. So that's really handy and when refactoring, I find. And of course, you've got the same thing in other statically typed languages like Java and Scala. So, but I wanted to just make an analogy with databases. So databases historically are statically typed, right? You have a schema, you know, you say, okay, you know, this table is these fields, and this field is this type, and maybe it's unique constraint on it, or it's this many digits or whatever, right? So there's sort of, I think there's some analogy there with statically typed languages. These new databases, these NoSQL databases, are generally dynamically typed, so they're a little bit more like dynamically typed programming languages. And once again, I think there's trade-offs and pros and cons of both approaches. Obviously, with the static typing on the database, this helps ensure sort of data quality or hygiene, right? But on the other hand, it's going to make some things harder and or just take more time. But there is something interesting, though, which is the really powerful thing we get with programming languages, the compile time errors. We don't get that with the database, even if it's statically typed, generally speaking, right? So, you know, if you do something like this, which is, you know, pretty analogous to the statements above in SQL, I'm going to get a runtime error if X were declared in the schema as a number, right? So I've got a static typing. I get some advantages of it, but I don't get as much advantage, I think, as I get on the programming language side. So I think it's just an interesting observation. I'm not sure what the conclusion there is, but is that it's not quite the same. Look at one more example. I'm actually going to flip over to a shell and just do a couple things in demo style. So first, I'll just spin up a database that already exists. Okay. I'm going to go over here, and I'll connect to it with the administrative shell, which is a JavaScript read eval print loop. I'm sure some of you guys have played with MongoDB, but not everyone. Okay, so there we are. And this isn't JavaScript, but it's an extension. Okay. So what I'm going to do now is query this collection. Just give me everything. And this is a parts database or an inventory or SKU database is kind of the idea here. I've only got a couple documents in it. And here, I'll do it in the abbreviated format like this, which is not very pretty, but fits on the screen. Just first, just let you see that for a second. So I've got a couple items in here that SKUs, basically, right? This could be an e-commerce site, or it could be for our warehouse, or it could be the items we sell if we're a supplier, right, for a product catalog app. You can imagine something like this in any of those use cases. So let's go back to the longer format version. Okay, so here we have one product or SKU, the ID, description, quantity, and some other fields here, like dimensions. And you'll see we're doing some nesting here, some specs. So this is a ball bearing, so there's actually an ABEX spec for it. So like if you're road skateboards, you would know this. I don't, but I know this, and so forth. And then tags, an array of tags. Okay, so that looks pretty good. But note that just putting this in here was very easy. If we did, what would we do in relational? And it wouldn't be hard to do in relational here, but these would just probably become columns. Tags would probably become, because there could be multiple tags, that would probably become a second table, right, with a foreign key relationship back to here. Item parts underscore tags or something. That would work fine. The one thing that's a little strange is this thing here, these specifications, because suppose if the only thing you sell is ball bearings, that you could just have an ABEC column, right? But if you're, say you're Amazon and you sell ball bearings, which they do, you probably don't want an ABEC column in your parts table, right? Right. In fact, I'm sure you don't. So you know, what do you do then? So this is sort of where you get into, it's not Agile per se, but rather just the types of data we work with these days is often the data is polymorphic. And not just our programming languages, but the real world data is polymorphic, right? So Amazon sells lots of SKUs. Some of them have this property ABEC. Most of them don't, right? So I think that's an example of polymorphism. You know, if you were a telco and you wanted a database of all your products you sell, you know, you've got phones, you've got service plans, you've got extended warranties, you've got accessories. These things are different. They're polymorphic. They have different properties, right? Service plan has a term, has a price per month. The phone has a price, right? So there's a lot of polymorphism in real-world data we do these days. We all organizations kind of need like an accounting system, a general ledger, and that's not very polymorphic, but that's already written, right, and already rewritten. So I think there's a lot of this type of data in the real world and that we need to deal with, and how easy or hard is it to work with. So what would you do with this in relational? You know, if we're building an e-commerce site and less than 1% of our inventory is ball bearings, you know, we're probably going to have a collection or a table, you know, parts underscore specs, you know, where it has, you know, it'll have a field, you know, well, first of all, there'll be the SKU or the ID, and then we'll probably have spec name and then the value, right? So it's sort of a little bit like a key value store in the database. And that's good, but the only thing is, you know, what if all the specs aren't numeric values? You know, if we added, in fact, let's do it. I think I had it ready to go. Yeah, if we added color blue as a spec, hopefully I don't have a typo here. Yeah. Okay, so if I have a collection that's kind of part specs, you know, part, spec name, value, well now I kind of need a string value and a numeric value. And you know, maybe I want to query for all the bearings that have ABEC greater than or equal to 5, right? So I don't want to just make everything, stringize everything. So you know, it's sort of like, you know, how do we deal with that real world polymorphism? I think these new products are good at that, right? So that was the point there. And then here's an example of iteration. You know, these SKUs up above didn't have a vendor field. And maybe you would have done that up front, but let's suppose we didn't, so we want to add it now, iteratively. So we could do something like this, or you can imagine adding a completely new SKU that has a vendor field, like that. And you know, the product, or the products in general, they're not going to mind that not every part has a SKU, right? And you know, often in the real world, there's sparseness to these properties in general. It's not just that we were being agile and we hadn't gotten to it. Sometimes they just don't always have them all, right? Not every product on Amazon has a vendor or, you know, supplier name, right? And the products won't care if we want to query on that. You know, if this field is missing from a document, which it is from one of the 2 documents in this collection, it's just going to evaluate to null, which would be a lot like the dynamic programming languages, dynamically typed programming language we use. A lot of them do that. So it's a little bit like duck typing, if you will. But it can be quite useful when you're iterating, you know, because, you know, we can do what we want without any issues. So it's, in a way, it's very simple, so it seems almost trivial, but it's not the way we've done things historically, right? So that's kind of the point. So shifting topics slightly, I just want to talk about kind of service-oriented architectures. Is this, because I think this impacts that also. Who here is doing service-oriented architectures in your systems? And I think service-oriented architectures are a great idea, right? Building big monolithic apps is a bad idea, in my opinion, because you kind of end up with big teams and mythical man-month problems. So, and it's good for other reasons too, I think. But you can imagine here we have this picture. Imagine just that, so no database per se, but we have these services, not web services, just services in our infrastructure, A, B, C, and D. And we have this piece of data, which I've formatted as JSON here, but you could imagine it being in any format, you know, XML or protocol of efforts or whatever. And it's going to flow through these services, right? A is going to send it to B, or B is going to pull it from A, either way. Then relayed on to C, it does something, and then on to D. Okay, so that's the example here. And the question is, if we're iterating, suppose now that we want to add a new field to this object that's flowing through here, right? So we want to add this location field. Maybe we're doing something with mobile or something, and because my example is just kind of gibberish. We add location. So we've modified service A to include that field in the documents it passes along. And then we're also going to modify the code for service D to consume that field, right? But the question is, if I do that iteration and do that release, do I need to change B and C? And the answer is it depends. It depends on what you were using, right? If you're using something that's strongly typed for the, you know, for the format of these objects that are, or serialized objects that are flowing through the system, the answer is yes. And you know, you might say, well, that's okay, but I could argue it's not okay. You know, what if your system is big and complicated and you have 200 services as part of it, right? You certainly don't want to, every time you change something on just 2 services, to have to release all 200, right? So in the perfect world, this can flow through from A to D without a release of B and C, I claim, right? So the point being that I think this dynamic typing notion is quite useful here too when you're doing these sorts of things. You know, I don't really want to update those two in the middle in this particular case. And note, you know, I may be using Java here, right? And I'd still want to be able to do this, right? I'm using a statically typed programming language for A, B, C, and D, you know, but I still don't want to do a new release of B and C. So on some of the formats for serialization, well, JSON, for example, that would not be a problem. On some of them, they're strongly typed, partly for data integrity reasons, but partly also for efficiency. Then you don't have to have all the field names as you pass it through the network. So there's different options there. So, but personally, if I were a CIO in some company and we were building a, you know, giant internal infrastructure and we had 100 web services, I would want to do something more like this. And I guess you could do this in XML too. I mean, I personally prefer JSON for a couple reasons. You know, one is just that it's more human readable, and we do have a few types. You know, we have integers and booleans in addition to strings, and we have arrays and nulls, and so we have a few types. And then MongoDB actually uses something internally called BSON, standing for binary JSON, which is a binary representation of JSON. And BSON actually adds a couple extra types. It adds a date data type, for example, and well, the 2 most important ones would be a date data type and a byte array or bin data data type. So, and BSON can be used without MongoDB. You could just use it all by itself. For example, you could use it for something like this. A couple other thoughts regarding development that might not per se be about Agile, but I think they're just good things to do that are changes from the past, right? So the first one is store first and ask questions later. So best practices historically, and I'm old so I remember, is to, you know, you store what you need, right? Storage is expensive, RAM's expensive, computers are expensive. Store what we need, you know, drop everything else on the floor. I'm not using it, why should I store it, right? So these days, we're getting to the point where computers are cheaper and faster, and especially if we have scale out, store everything, within reason. If you know you're not going to need it, don't store it. But so it's sort of, we store the data speculatively in case we need it later, in case we need it a year from now or a month from now or 3 years from now. If we have it stored, we can do analytics on it. If we don't have it, we can't, especially if you can't go back, and especially if it's going to be lost forever, right? If it's some historical thing. But I think computers are getting fast enough that we can do this. And I don't know, maybe there's a little bit of analogy there with, CPUs do speculative processing, right? Because of branch prediction, right? Where they'll actually execute 2 paths, and they don't know where you're going to go until the branch is taken, and then that other work was just thrown on the floor. I mean, that's proven to be quite useful. So I don't know, maybe there's a little bit of analogy here, because you're definitely going to store some things you never use, but I think you're going to store some things that you come back to and say, oh yeah, that is useful, at least for something. Maybe it's useful for the data science team, or maybe we actually use it in an app later. But I think it's a good notion, and then it's an inversion of best practices, which is from the past, which is why I bring it up. Another one, which same thing, I think it's an inversion. If you buy it, it is an inversion. Is default to real time, right? So 20 years from now, 20 years ago, if we go back in time 20 years, default to real time was definitely not the best practice. The best practice was default to batch, because batch processing is efficient, real-time processing is inefficient, it tends to create random I/O. So computers are expensive, disks are slow, random I/O on disk seeks is slow. Do batch, right? Today though, with solid-state drives and relatively cheap RAM, I think we can default to real time. Note the word default, right? I didn't say do everything in real time. I just said default. So if you imagine, once again, we're CIO somewhere, and we tell our tech teams, default to real time. So what that means is you can do batch, you just need a reason, right? So if you say we're going to do batch, that's not the default, I'm just going to say why. And you'll say, well, here's why. It'll be too slow or something. But I think the majority of things today can be done in real time. I don't want to get daily reports in the morning. Give me real-time reports. Why not? A lot of times it would be possible. So I think that's another kind of almost methodological change that's worth noting. And I think we do this sort of intuitively, right? I bet a lot of us here in the room do. But it's kind of nice to kind of state it as kind of formally, semi-formally. All right, thanks everyone, appreciate